set your window, to use your table to set your window with. Now, when you're doing this, can everybody set their window now according to their table? Look for the lowest point to highest, but we only made it from -5 to +5. Yeah. So if you set your t from -5 to +5, and you put this in your parametric, you have your parametrics on, okay, and you put this in your x1, your y1, when you pull this table out, sometimes you can't see this in your window. So you look at these values here. Your t, we know your t because we set it, and your t start with like 0.5 or 0.3. Then your x goes the lowest from -5 to the highest to 5. So your x min should be -5, your x max should be 5. Your y min goes the lowest from -10 to +10. That's how you want to set your window, so that that's the piece you see. Now again, your t step, set it to 0.5, change it to 1, change it smaller, change it larger, then see the difference in it. It is just making it smooth and as best as you can. Look for your orientation. Orientation is another thing I want you to watch. Orientation says, I want it to start at the smallest number here, when this is the point that I graphed right here. So therefore, then I graphed this one next, then this one. My orientation went like this. The orientation, or the direction that it's going in. It's not as important on this little line segment as when we do an ellipse today and everything else. Now, here's the thing. Today's lesson is we're going to do this algebraically. We're going to actually, if you just look up here for 1 second, you don't have to write this because I'll do this again in a minute. But we're going to substitute for t. We're going to solve for t, for x, and then we're going to substitute that into the y. So how nice is this, that x is solved in terms of t, right? So now we can take this t out of here, and we can substitute in t is equal to x. I can substitute in x. So therefore, isn't that the equation of that line? Y equals -2x. My slope is up to over 1 negative. Here's my line. It's passing through the 0, 0. Isn't that the equation of that line? On your coordinate plane, we used your parametric to get there. But we can take the parametric out of it and find the equation in our coordinate grid, in a rectangular plane. We'll spend more time with that today. But that's where we're going today with this. We're going to do the same exact thing you did for homework, but we're going to solve it algebraically so that you can now, if you took your calculator and you graphed y equals -2x, you would have these points on it. That would be your xy table in your graph. Okay, this guy, again, parametrics, put it in your x1, y1. Your domain for your t is still -5. We made it -5 to +5, just so that you'd have a flavor for that. When you set your window, here's your minimum x, -16. Here's your maximum x, 14. Minimum y, -9. Maximum y, 11. And that'll help you graph that. Okay? Was everybody able to put it in your calcs and graph these? I really like you to look at the table, because tonight, again, you're going to solve in terms of t, and then you're going to make a rectangular equation, and you can put that in your y1, and you can check that your graph is exactly the same, because all of these guys are your xy coordinates. -16, -9. Okay, here's a 0 when you're -1 at your 0, -1, 1. You're here. I want to find this guy. I can't find that guy here. 2, 3, 5, 5. See it? Those are your points that when we solve this today, you're gonna see a big difference. Okay? Alright, this one, same situation. Look how small your numbers are. If you tried to view this graph with the table that you had from your last one, you wouldn't see much of it because look how small those x values are. Most of them are under 1. So your x is going to be so small. And here's another thing. Your x minimum here your x minimum is like negative 1.5, negative 1.25, whatever. Your maximum is 1.25. If you set your scale to 1, you'll still see it all. You'll just have a big gap where they have 1. So you can even set your scale if you wanted to 0.5, so that you have a little bit more tick marks as a reference. It still graphs it in that space. It's just your tick mark is a little harder to figure out where your points are. Are you getting a little comfortable with your window? Now, your orientation, you should watch. When you graph the parametrics, you're going to see it starts from this point right here. Negative 1.25, 25, way up here. So it's coming down like this. There's your orientation. And then it's coming up. There's your orientation. The direction it's coming from. So you guys are pretty good with this, I take it. Probably the most difficult to play with is your t-set, right? And play with it. Make it be large, make it be small, and see what it does to what you thought was going to be a parabola, and see what it does to it. Sometimes if you speed it up too fast, it just gives it like a jerky motion because it does 1, 2, depending on how big your x is. These x's aren't too far apart either. So if you don't make your steps small enough, it kind of gets a little bit jerky when it's doing it. It's not as smooth. There's not like a set way to do it, just kind of like play with it. And this is the last one, I take it? There's the last one. Now, this one again might be a little hard to find, so you might have to fine tune after you do this. If you want to see what's happening right at your origin, you might want to fine tune it. I mean, some of you were able to give me a little sketch, but if you want to see, does it dip below the line? Does it come up above the line? All your y's were positive on this. And it hit the 0, 0 as the smallest point. Sometimes you can, rather than narrow it down, you can see it off your table. Good? Okay. Now, today's lesson, if you take a look at your lesson, here it said, solve for t in one equation, and put a little x next to that. You should solve for t, okay. I'll come off of this homework. You're going to solve for t. This should say in the x equation. You're going to solve for t, and then into the second equation, the y, we're going to substitute in. The reason we do it in that order is because then this one is going to be set up to be y equal. And that's what we're looking for, so that we won't have to switch anything around. Your result is one equation in one coordinate plane. We call it a rectangular equation, a rectangular plane. And we're going to show graphically that it works. Okay? Now, your second homework that you had last night, before we do this messy problem, I want to look at your second homework problem. It'll be a lot easier if I do a simple one and then do a messy one. So, your second homework problem was this. Okay? And what kind of a shape did you get out of this? What equation did you get? What was your graph? A line. Where was it passing through? Okay? We looked at it before and I didn't want to switch it. Is it a positive slope like this? Okay. Now, keep handy your table for this. So we're going to follow your rules for this. We're going to solve for t in your x equal. Just to transformation. So I add 1, God bless you, and I divide by 3. Okay, we solve for t. Now, replace this, which is the equivalent of t, into the t for your y equation. We need to make one equation. We plug the x into the y. That sets us up for y equals. So we take this equation, and we take the t, and we replace it with its transformed x part, because we don't want the t in there anymore. We're eliminating the parameter. Going back to just the x and the y. So now when we plug this in here, we're plugging in over 3. Okay? Now, you have a couple of different ways you can do this. You can distribute this over. You can multiply it and distribute it. You can get rid of your denominator first. Whatever you feel like doing first. I wouldn't really get rid of my denominator by multiplying, because then you're going to change your y. So let's just take an easy path here. I did pick a hard one, I guess, to start with. Let's just combine this like this for a minute. Okay, let's combine it like that for a second. Now, make this into one denominator. So what is your common denominator here? Between 1 and 3, I need 3, right? So this is my numerator stays the same. This was a 1, so I need to multiply my numerator by 3. Now, I'm going to combine my numerator now. I'm going to distribute this guy. So I'm getting 2x plus 5 over 3. That's an equation of a line. So I'm just going to separate this so it looks a little bit better. 2/3 x plus 5/3 equals y. There's the equation of your line y equals mx plus b. We got a line here, right? We got a line right here. Now, when you do this and you put this into your calculator, God bless you will get the same coordinates as you did on your table for your x and your y. We're eliminating your parameter and we're making one rectangular equation. And it should be some kind of a graph that we saw when we did this out with your parametrics. If you put this in your y equal and you go to the table that you did this one, those coordinates will be the same. Make a little sense? Okay? Now, I'll go to the tougher one. The one. No? We're good?
Saying that wasn't the tough one. Yeah.
This wasn't the tough one, no. Yeah, but it was like the first one that I did, the easy one. The t just plugged right in. That's a line. We saw a line. That was kind of nice. Nice and easy line. Some of them obviously going smoother than others, and we're going to see some today that are a little bit nicer than others. So here's one, and this one's a little bit tougher. So let's start with this guy and say, okay, I need to go to my x equation. And I need to solve for t, and then I'm going to plug t into my y equation so that I will get one equation that says y equal. I can go to my regular screen, y equal, and I can get a graph. Now, unfortunately, this has a domain restriction. We have two denominators. This denominator, I have to set greater than 0. I have to set so it's not equal to 0. So t cannot equal -1. Agree? T cannot equal negative. If I put a -1 in here, I have a 0. It won't work. In this denominator, I have a radical. This radical normally has to be greater than 0, greater than or equal to, but because we're in the denominator, it has to be greater than 0. So t has to be greater than -1. So therefore, I can't use -1. So my domain restriction says from -1 to infinity you can use. You can't use anything less, because we're going to have a problem with our domain restrictions. Okay? Combine them. See which ones that you need to use. Alright, so now, let's come over here and solve this guy for t. Alright, what should I do first? Square. Okay, I can square it first. Square both sides. Chris wants to get rid of the radical. I need to get t by itself. What would you do? You can cross multiply. You can send them out like that. You can, do all that. I'm going to just take a shortcut through this. I'm going to take this guy and I'm going to flip this over. Watch. Can I flip both of those over? I kind of am eliminating a little problem here. Do I really need to divide by 1? No? So I got this. I'm solving for t. I'm going to subtract 1. Now, my problem is, I can technically plug t in for that, but, yeah, no, maybe we will. Maybe we will plug this in first. Let's take this, and then worry about correcting this later. Let's now plug this in to this t right here. I think it's going to work out better. So we're going to get y equals t over, I'm plugging this in, and we still have a plus 1. Not so bad. What happens to the -1 and plus 1? Cancels out. So we're left with t over 1 over x squared. Now, we can't leave a fraction in the denominator, so we say keep the first, flip, and change. Oops, we forgot to take this t out. My mistake. We forgot to take that t out first. So let's put that t in there also. No, that doesn't come out pretty. Alright, so let's work with this. So, instead of flipping, let's find, I told you this one wasn't as pretty. Let's make a common denominator. Look at all your denominators. What's your common denominator? X squared. So every term is going to get multiplied by an x squared. So x squared comes out, and we get 1 minus x squared over 1. So how bad is that? Whoops. My board is a little bit off here. So, what is that an equation of? A parabola, and which way is it opening? Down. Got the negative in front of the x squared. Now, my only problem here is this. We have a domain restriction. We have a little bit of a domain restriction. Now, did I put the graphs on your paper as well? On the bottom? No. I did. Okay. Now, if you look at your parametric one, so look on the bottom at the left-hand side, there's your parametric one. It took care of the domain restriction for us. Are you okay with this before I move this? I'm not so sure if I put it here. Yep, it did. So we got this as our new equation. So your parametric one, we put it in your function parametric. We did this. Then we found this to be the case for our rectangular graph. We put it in your regular y1. We graphed it, but we have a little bit of a domain restriction here. We have to remember that we have a domain restriction up here. So we're only, instead of your parabola coming like this, We don't want that part of it. We only want this part of it. Okay? So even though your rectangular will give you an entire piece of it, you can restrict your domain on this. Actually, it should be greater than -1, but I can't use the negative, so we'll go back to the 0. Okay? So that's what these are going to look like. Now, I think it's going to be a little bit more obvious when you do your homework ones because you did your table last night. So when you do it, you're going to put it in, like I gave you this piece here. When I graph this, I should see these answers. Of course, I'm not going to get these x values, right, in my table, but I can always do a calc value on that and put it in my calculator. If I put this in my calculator and did a value on it and put these x's in, I would get those numbers. So you may not see these on your table, obviously. You might see this one, that one will be there, but the rest of them won't. But you can do a calc value on your parabola and see if those values are there. Make it a little bit easier. Now, some of these work out a little bit nicer. This guy, we're going to sketch a curve represented by, here's your parametric. Here's your x1 and your y1 with your t, right? Your parameter this time, when you go to put this in, is actually your t. This is going to be where your parameter is going to be, in your angle part right there. So now, instead of doing this, we're going to eliminate the parameter and we're going to make one rectangular equation. This is the part that I was waiting to show you because these are where your conics come from. Now, I start like this. I need to solve this equation for t. But you can't separate cosine and angle, right? So you're going to have to solve for that by itself. You can't say take my t away from my cosine or my angle. It doesn't mean anything. So this is where my parameter would be in here. So I'm going to solve in place of this. Gianna's pen thing, she sees trig functions. So in order to get this by itself, actually this is kind of nice stuff. I'm going to divide both sides by 3. Okay, and I really can't now substitute this into my y because I don't have a cosine in here. My angle is my parameter, and I can't substitute in my cosine and my sine. So therefore, I'm going to solve this guy for sine. We're going to get rid of your trig in here. So we're going to divide this side by 4. Because I can't interchange that. My angle is my parameter, but I have no choice. I can't separate my sine and my cosine. We have one trig identity that you had to memorize. Anybody remember what it was? Good. Sine squared plus cosine squared equals 1. That was Pythagorean's identity, right? X squared plus y squared equals 1, and we substituted them in. Now, watch how nice this is. If we take out your cosine and we substitute in this, we take out your sine and we substitute in this. So y over 4 squared plus x over 3 squared equals 1. Let's work this out. This is y squared over 16 plus x squared over 9 equals 1. What's that an equation of?
Stuff we had
The stuff we just did, right? There's your ellipse. What's your center? 0, 0. Which one is your major axis? The y, because it's larger on the bottom, not because it comes first, but because it's larger. So look, your y went up 4 and over 3. There it is. There's your ellipse. So we took your two parametric equations and we made one rectangular equation. Now, in our rectangle world, we can't graph this. In our parametric world, we can graph this. Because our parametrics graph graphs that are not functions. In our regular y equal, we can't graph. a non-function unless we separated them into two equations. But your parametrics do it all at one time. Now, when you put your parametric in, again, if you put it in your x1 and you put it in your y1 and you do these guys, you put them in, you're going to have to set, this is your t now, you're going to have to set your t up as an angle. So, in other words, we go all the way around here. We have to go 360 degrees to come all the way around. If you stop it too short, your ellipse actually stops wherever you stopped your angle from turning around. It's really not a trig function like as you read it, but you just kind of have to know you have to go 360 degrees. And this time around, look at the big disparity from 0 to 360. So now your t-step 1 isn't going to cut it. It's going to go too slow, and you'll hardly ever come around. So we increased your step. And this really is whatever it is. Like if you notice this is a 4 by 3, you can go -5 to 5 on this. That's not a bad situation there. You can change that. So here you have a parametric that will graph an ellipse. So we took that formula and we converted it to your y equals formula, which is your ellipse. Well, actually not a y equals in this case. Okay? You all look so overjoyed. I thought you'd be excited to see your parameters turning into these. Okay? One more. One more. And no, you won't have to worry about memorizing this. I will give you the equation. Should you need it, should you so desire it. Okay. Now, I'm going to eliminate the parameter again, but remember, in this case, this is my t, so I can't really substitute one into the other, but I can solve for that. So I'm going to take the x guy. I'm going to subtract h. Oh, it's kind of looking a little familiar. Subtracting h, right? Oh, yeah, you know your x minus h, y minus k thing. I'm going to divide by r. Looking even better. And I solved for cosine. Kind of looking similar. Now I'm going to come here and I'm going to do the same thing. Solve for sine. I'm going to subtract k. Whoops, there's my y minus k thing. Divide by r. Now when you have a sine and a cosine, you know your one identity, cosine squared plus sine squared, and it doesn't matter what order you put this in, equals 1. Because it's a plus sign, doesn't matter. So we plug in what we found for cosine, we square it, we plug in what we found for sine, we square it, and now we just kind of distribute, do the raised to the power thing. So we get x minus h squared, over r squared, plus y minus k squared over r squared equals 1. We have the formula for an ellipse. This is a special ellipse because your two denominators are the same, right? So what kind of ellipse is this? A circle. So why don't we just multiply everything by r squared and get rid of it? So we have x minus h squared plus y minus k squared equals r squared. So we developed a rectangular formula for your circle. So now, we can find the two parametric equations that solve for this. We can go put your center in up here. This is your hk. We can do it again, or we can just plug it into here. We can plug it back up into those, or we can plug it into here. So since we went through this part, we can plug in your center, x plus 3 squared plus y minus 1 squared equals 3 squared, which is 9. And there's your center for your circle. So if you map this out, okay, your center is -3, 1, and you went all the way around and did this, and you did those two parametrics by plugging this in, plugged in an R of 3, you would get your parametric of your circle. Remember, it's only the parametric that will graph the circle. It's not your rectangular one.